Two capacitors C1 and C2 are connected with two batteries of emfs E1 and E2. The circuit components are connected with a switch S as shown. Initially, the switch is open and the capacitors are charged. Find the heat produced when the switch S is closed. The corresponding picture is here, and we are seeing two batteries E1 and E2 with the two capacitors C1 and C2, and here is the switch. There are two situations in the question. Switch opened and then the switch closed. Finally, we have to find how much heat is going to produce when the switch S is closed in the two capacitors. So I'll do the work like this. Initially, I think when the capacitor are connected, when the switch is opened. Okay, so now I am doing the calculation for the switch opened. For the switch opened, that is initial situation. So here it is said capacitors are charged. Okay, so initially the capacitors are charged. So I simply assume the positive terminal of the battery connected to this plate of the capacitor. So it may possess a charge plus Q2. Okay, so correspondingly here there will be minus Q2, and the positive of the first battery is connected here. So this is having a charge plus Q1, and the corresponding charge in the second place is minus Q1. Okay, so first of all I have to find how much is the value Q1 and Q2. For that I simply assume a situation like this, the point which is said here is at 0 volt, and this is at some x potential. When I come from this point to this point, a potential 5 volt will rise. Correspondingly here the potential is x plus 5 volt, and the same point is here, right? Same potential should exist, so it is also x plus 5 volt. And on this side it is positive 10, right? So it should be plus 10 volt, and this must be plus 10 volt. This is the situation. For this I am suggesting you that net charge in the whole system is 0. Okay, so plus Q2 and minus Q2 it is 0, and plus Q1 minus Q1 it is also 0. Therefore net charge in the system is 0. See, that means when we take a portion of this capacitor system like this, in between the plates and in between the switch, when I come like this, okay, so this much part, remaining portion is here. These two are having equal and opposite charges. So considering this one, I am doing some procedure like this, so for this one, okay, for this capacitor, the charge in the capacitor is calculated like a CV. Okay, so for the first capacitor the charge is Q1 and this V1, and the potential difference existing between the plates is said V1. Okay, so that is Q1 is equal to, how much is the capacitance of this capacitor, which is 2 microfarad. I am simply taking 2 micro, and the potential difference existing between the plates is x plus 5 and 0, right? X plus 5 minus 0. So definitely it is 2 micro into x plus 5. So meantime I can find Q2 in the same way. Okay, so Q2 is equals to C2, right? C2 V2. That means what? Q2 is equals, C2 is 3 microfarad, and in the bracket I should take the potential difference with respect to this plate. So it is x minus 10, right? X minus 10. So it remains as it is. Okay, so nothing can be done further. What I said, the sum of these two charges is 0, right? The sum of these two charges is 0. So I can take this negative sign here also to show you further. Now what I am going to do is the sum of these two charges, that means since the net charge in the system is 0, right? What I can do, I can simply say Q1 magnitude, okay? So and this one, which is this much, which is plus of minus Q2, so it is 0. So that means what I can do, I can simply add these two terms. Therefore 2 mu x plus 5 plus 3 mu x minus 10 is equal to 0. So further what I can think is, when I bring one term or complete of this term to RHS, it becomes 2 mu, right, x plus 5, and on this side it is 3 mu into 10 minus x. So this can be written, right, this one, and further it becomes now the term mu get cancelled. It is 2x plus 10 is equal to 30 minus 3x. So when I solve this, it becomes 5x is equals 20. Otherwise I may say x is equals 4. Okay, the term x is equals 4. So I got x is equals 4. That means this point where I can write this point is equal to 4 volt. The x is 4 volt, and this is at 4 plus 5, which is 9 volt. This is also at 9 volt, right? So every point is now with numerical values. Now I can find the values of Q1 and Q2. Therefore Q1 is equal to, magnitude of Q1 is equal to, what I can write, it is C1 V1, right? C1 V1. C1 is how much? C1 is 2 micro multiplied by V1 is the potential difference, that is x plus 5 and 0. X is x plus 5 is 9. 9 minus 0 I can write. So it is 2 micro into 9, which is 18 micro coulomb. So what actually the meaning of this? The meaning of this is, on this side we are having plus 18 microcoulomb, and on this side we are having minus 18 microcoulomb here. And meantime I can simply find the charge Q2 in the second capacitor. The capacitance is 3 micro multiplied by, with respect to this plate, the potential difference is x minus 10. X is 4, 4 minus 10. This is 3 micro into minus 6. So it will be minus 18 microcoulomb. I am simply considering the magnitude, right? I am simply considering the magnitude. That means this is at minus 18 microcoulomb, and this is plus 18 microcoulomb. This is the amount of charge in the two capacitors. Okay, so further what we can do is, we can simply think now about the situation when the switch is closed. Okay, so now for the switch is closed. Okay, so now the switch is closed. When the switch is closed, the whole situation looks different. The first battery remains where it was. Second capacitor is here, which is 3 microfarad, and this is E1, which is 5 volt, and here is the first capacitor. C1 is equals 2 microfarad, and there exists the second battery with EMF E2 is equals 10 volt, right? Now these two terminals are shorted. These two junctions are now shorted because the switch S is closed. When the switch S is closed here, the middle portion looks shorted like this, right? So now the potential at this point is 5 volt plus 5 volt, and this is 0. That means the two terminals when shorted here, right? So this is also at 5 volt and this is 0, and here it must be plus 10 volt. Meantime here also plus 10 volt. And now I have to do further. Keeping these things in mind, what I can do further is, the situation may look something different now. The capacitors may have different charges. Let me say this is the situation where this plate is possessing a charge plus q1 dash and minus q1 dash, and this is plus q2 dash and minus q2 dash. Okay, is my assumption. Now the capacitors have different charges, and we have to evaluate now the values of q1 dash and q2 dash. Okay, so that is what I am going to do now. What is q1? The magnitude of q1 is, okay, so q1 dash is, right, that is a c1 into the potential difference. C1 is 2 micro multiplied by the potential difference is 5 minus 0. So it is 2 micro into 5. This is 10 microcoulomb. Right. Meantime, what we are having? We are having q2 dash, that is equals, the capacitance C2 is 3 micro multiplied by the potential difference is 10 minus 0. This is 3 into 3 micro into 10. It is 30 microcoulomb. The meaning of this is, 10 microcoulomb is here, that is this is equals plus 10 microcoulomb, and at this point it is a minus 10 microcoulomb, and on this side of the plate we are having minus 30 microcoulomb, and on this side it is plus 30 microcoulomb. This is the answer what I got here. Okay, so be careful about the signs. And now I have to find the amount of charge that changed, okay, transferred. To find, okay, so to find the amount of charge transferred, transferred, okay, so transferred in first capacitor in C1, it is delta Q1 is equal to, okay, so Q1 dash minus Q1, which is equals, initially the first plate was the first capacitor's first plate was with plus 18, and now it is plus 10. So that means plus 10 minus plus 18 should be written. Here it is plus 10 microcoulomb, right, minus of plus 18 microcoulomb. So this is equal to, how much I can write? It is 10 microcoulomb minus 18 microcoulomb. This is minus 8 microcoulomb. Right. So this is the amount of charge that transferred in the first capacitor. And in the second capacitor in C2, it is delta Q2 is equal to Q2 dash minus Q1. So you can observe here, Q2 dash is 30, right, and Q2 is 18, right. So what I can write? It is plus 30 microcoulomb minus of how much I can write? It is a plus 18 microcoulomb. Here also minus plus 18 microcoulomb. See, it is where here it is plus 30, this plate, and the positive plate is where here it is plus 18 initially, and this is final. So that means what I can write now, it is 30 microcoulomb minus 18 microcoulomb. This is equal to 12 microcoulomb. This is the amount of charge that transferred. Therefore, work done by the battery, batteries, say it is a delta W1. First battery is doing some work. So how much work is doing here? So the amount of work done is what I can write. It is a delta Q1 into the potential difference of the first battery. So this is equal to the amount of charge that transferred is minus 8 microcoulomb, right, into the potential difference now existing across the capacitor is 5 and 0. So it should be written here 5 minus 0, it is minus 8 micro into 5. This is equal to minus 40 microjoules. This is the amount of work done by the first battery. Meantime, I have to find the amount of work done by the second battery. That is delta Q2 into V2. So delta Q2 is 12 plus 12 microcoulomb into the potential difference existing across the second capacitor now is 10 minus 0, right? So it should be 10 minus 0. It is how much it is? It is 12 micro into 10. So this will be is equals 120 microjoules. This is the amount of work done by the battery for the second capacitor. Therefore, total amount of work done by the two batteries. So total work done by two batteries together. Two batteries is W is equals. Okay, so W is equals, it is delta W1 plus delta W2, that is equals of minus 40 joules, microjoules, right, and plus 120 microjoules. The answer will come, how much it is? It is 80 microjoules. So this is the amount of work done by two batteries together. And now I have to find the amount of internal energy that changes in the two system of capacitor. How much energy was here and how much is now, and similarly here also how much energy was here and here. For that, for first battery, okay, so now to find change in internal energy, change in internal energy of the capacitor, internal energy of the capacitors, that is what I have to do now. For this, in the first battery, that means first capacitor, it is a half, right? C, the potential difference now, that is C1. What I should write is a difference in the potential in the beginning, in the final, it is what I can write V2, V1 dash square, it is a final, okay, so I may write it final, minus half C1 V initial square, okay, it is better scenario, so it is better for me now. So U1 is equal to, half is common in both, C1 is how much? C1 is 2 microfarad, both capacitors, right? This is also common. And how much is VF? VF is 5 and 0. 5 and 0 means it's 5 volt is the potential difference. So it is simply 5. So I should make the square minus what I can put here now for VI. V initial is it is 9 and here is 0, it is 9 volt, right? So 9 square should be written in the bracket square. So this is U1, which is equals the change in U1, right? So change in U1, this is equal to it is simply 1 mu in the bracket. What I can write, it is 25 minus 81, right? So delta U1 is equals it is minus 56, right, microjoules. This is the amount of internal energy that changes in a first capacitor. Similarly, I can do for delta U2 in the second capacitor. It is again a half C2, right, Vf square minus half C2 Vi square. So delta U2 is equal to half into what is C2? C2 is 3 micro, right, and in the bracket the final potential difference is here when the switch is closed, right, it is 10 and 0, it is 10 square should be written here, right. So it is 10 square minus how much was the initial potential difference across the same capacitor. This is final and this is the initial situation, so it is 4 and this is 10, it is 6 volt. So 6 volt is the potential difference. So I should write 6 square should be written here, and this will be is equals, what I can write now is it is 3 divided by 2 micro, and in the bracket what it will be, it is 100 minus 36, right? So it will be 64. So it is 3 by 2 micro into 64, and this is 3 micro into 32, and this is definitely 94, right? 96, it is a 9 and 3 2 is a 6, 96 microjoules. This is the amount of energy that changes in the second capacitor. Therefore, total change in internal energy, is how much? It is delta U equal to delta U1 plus delta U2. So delta U equal to, so it is minus 56 microjoules plus 96 microjoules. So this is nothing but what I get. This is equal to plus 40 microjoules, right? This is the amount of internal energy that changes. And finally what I have to do is, finally I have to do like this, so final step is going to be written here. This is a final step. It is to find heat produced. Okay, for that what I suggest is the formula is amount of work done is equal to the net change in internal energy plus heat produced. This is the formula. For this what we can do, amount of work done in total is 80 microjoules, right, which is equal to how much is the total change in internal energy? It is 40 microjoules, right? So this two things plus heat produced, and finally if I want the heat produced, definitely H is equal to 80 microjoules minus 40 microjoules. Therefore H is equal to, it is plus 40 microjoules, right? Microjoules. So this is the amount of heat that is going to produce finally. Okay, this is our answer, final answer. So in the system of this capacitor, the total heat produced, what they are asking in the question, right? So how much heat produced? So the answer is 40 microjoules is the answer.